Today we are going to start one important topic from the chapter of calorimetry icse physics class 10. So what is calorimetry? Already we have discussed. So today we are going to discuss change of phase. So what is change of phase? Whenever any substance is changing its states, like from solid to liquid, or from liquid to vapor, or from vapor to solid, okay, so that type of process is called change of phase. In change of phase, certain definition is there, some term you have to understand first. So first term is, now suppose this solid is going to convert into liquid. So this process, the process in which solid convert into liquid, this process is called melting. So this one is melting. And now suppose I come reverse. Suppose liquid is going to convert into solid. Okay, so the process in which liquid convert into solid, that process is called freezing. Okay, so freezing, like हम लोग बर्फ या आइस जमाते हैं फ्रिज में, so that in that what will happen, the liquid is going to convert into what, ice. So that process is called freezing. Now when liquid is converted into vapor or gaseous form, so that process is called boiling or vaporization. And reverse of this is that when vapor or gases is converting into liquid, so that process is called condensation in reverse. Okay, now suppose solid directly convert into vapor, so that process is called sublimation. And vapor will directly convert into solid, so that process is called solidification. So this one is the change of phase. In change of phase, certain term we have to discuss. So first term is melting. So as we know that melting is what, the process in which solid convert into liquid at constant temperature is called melting. And melting point, what, the temperature at which this solid is converting into liquid, so that temperature, particular temperature, is called melting point. And this melting point is very and different, okay, for every substance. Like for water it is 0 degree Celsius, but for iron ball or for copper it is more than 0 degree Celsius. Now second point is boiling or vaporization. Boiling or vaporization is what, the process in which liquid convert into vapor at constant temperature, so that is called boiling. So there is boiling point. Boiling point is what, the temperature at which water convert into or liquid convert into vapor, so that particular temperature is called boiling point. For example, water has boiling point 100 degrees Celsius, because water is going to start converting into liquid to gases at 100 degree Celsius temperature. Our next point is freezing. Freezing is what, the process in which liquid convert into solid at constant temperature is called freezing. In freezing, what will happen, the water is going to, like, or liquid, any liquid is going to convert into ice. This one is ice. Okay, so that process is called freezing. Then the last point is condensation. So condensation is the process in which vapor or gases is converting into liquid. That process is called condensation. There are some key point or notes here which I have written, so you have to note down this key point. So first note is what, note first point is, whenever there is melting, okay, so whenever there is process of melting, heat energy is going to absorbed by the by the solid. Okay, and whenever there is freezing, so at the time of freezing, heat energy is going to reject. Okay, like suppose here, suppose I am converting this ice into water, so that time it is going to absorb the heat. And whenever I am going to convert this liquid into ice, this, there is rejection of energy from this water. So that is the first point. Now second point is what? For a given mass of substance, the amount of heat energy absorbed during melting is same as that liberated during freezing. Okay, so pure substance, what? Like water. Water is pure substance. Okay, so suppose we have ice. Okay, and this ice is going to convert into liquid. So this times when ice is converting into liquid, the heat energy absorbed is suppose 420 joule. Okay, now suppose we are doing reverse process. We are converting this liquid into ice. So that time whatever this time it is going to release the energy, and how much energy it is going to release, same as it is absorbed during the melting. Okay, so that is the point which I have written here. Okay, heat energy absorbed during melting is same as heat energy released during freezing. Now third point is what? During phase change, temperature and pressure both are remain constant. Okay, but here I have written only temperature. Fourth point is what? For pure substance, melting point and freezing points are identical. Means suppose ice is going to convert into water at 0 degree Celsius. Okay, so this one is the melting point of ice, that one is 0 degree Celsius. Suppose I will tell you what is the freezing point of ice. So the freezing point of ice is also how much? 0 degree Celsius. Okay, so melting point and freezing point both remain identical for pure substance. It is applicable for boiling and condensation also. Like water is going to boil at 100 degrees Celsius and it is converting into steam. Okay, now suppose in condensation this steam is going to convert into water. Okay, so it will this condensation will also happen at 100 degree Celsius. Now let's discuss heating curve. So what is heating curve? Let's explain with one example. Suppose we have one ice here, ice, and this ice is at minus 8 degrees Celsius. Okay, now I have to convert this ice into vapor. So what are the process it involves? First process is that this ice is going to, its ice temperature is going to increase. Okay, and it will attain the temperature of 0 degree Celsius. Okay, now again this ice, now in this both the cases this ice is in solid state. Okay, here it is also in solid, this one is also in solid state. Okay, ice, now this ice is going to convert into liquid. Okay, and I have told you that whenever there is change of phase, now in this, in between this there is change of phase. Okay, so during change of phase temperature remain constant, so this ice is going to convert into liquid at 0 degree Celsius, but now its phase has changed. Now it is in 0 degree Celsius. Now suppose we supply more heat, then what will happen? When we supply more heat, when we supply more heat, this water's temperature is going to increase, and up at certain time it will attain a temperature of 100 degrees Celsius. Okay, so at 100 degrees Celsius what will happen? This water starts boiling. Okay, so now this water is going to convert into what? Vapor. Okay, it is going to convert into vapor, but it will happen at again constant temperature. This one is vapor. Okay, now here also temperature is 100 degrees Celsius, because I have told you that this one is in liquid state, and this liquid is going to change its phase. Okay, it is going to convert into vapor, and during the phase change temperature remain constant. So this entire liquid is going to convert into vapor at 100 degrees Celsius. Okay, so this one is the process. Now suppose I have to show this process on a graph with time and temperature graph. Okay, time versus temperature graph. So how we will do it? First let's do some heat we have supplied here now. So what is the name of that heat? See here, there is increase in temperature minus 8 degrees Celsius to 0 degrees Celsius, and I have told you that whenever there is change in temperature, and that time suppose we are supplying the heat, so that heat is called sensible heating. Okay, so we have supplied here sensible heat. Now here there is phase change. Okay, so at the time of phase change we are supplying heat, so that heat is called latent heat. Again there is increase in temperature 0 degrees Celsius to 100 degrees Celsius, so this one is called the heat supplied during this process is called sensible heat. And again there is change of phase and temperature remain constant, so this one is also latent heat. Okay, so here there is sensible heat, here there is latent heat, here there is sensible heat, then again there is latent heat. Now I have to draw this one in graph. So let's draw one graph. This y-axis, x-axis we have taken time, and y-axis we have taken temperature. Time in second, this direction we have taken temperature. Okay, so suppose our temperature here, our origin or temperature, that origin we have considered as minus 8 degrees Celsius. Okay, so first temperature is at that one origin is minus 8 degrees Celsius, then this one is 0 degrees Celsius, then 100 degrees Celsius, zero degrees Celsius, then 100 degrees Celsius. Okay, now I am drawing the graph. So this ice is at minus 8 degrees Celsius. With time its temperature is going to increase. Okay, and it is going to increase up to this 0 degrees Celsius. When it reach 0 degrees Celsius, there is change of phase, so for some time its temperature remain constant. Okay, up to certain time, duration of time, then again its temperature is going to increase, so again there is increase in temperature. Then when it reach to 100 degrees Celsius, its temperature remain constant. And we further suppose we increase the temperature when entire, see here in suppose I am writing name here A, B, C, D, E. Okay, so in this graph AB, AB is called what? There is we are supplying sensible heat. Okay, so it has reached to 0 degrees Celsius. At 0 degrees Celsius there is process of melting. Okay, so BC graph will show, BC will show what? Melting process. Then again DE, DE will show which process? Boiling process. Okay, and this one is the sensible heat, this one is latent heat, this one is also latent heat, this one is sensible heat. Okay, so this one is heating curve. of the substance. Now let's discuss the latent heat. So earlier I have discussed that latent heat is the what? The heat energy absorbed or released by a substance during change of phase. Okay, whenever any substance is going to change its phase, so the heat energy released or absorbed during that change of phase, so that energy is called latent heat. Now there is one more term, that one is a specific latent heat. So what is a specific latent heat? The latent heat per unit mass. Okay, the latent heat per unit mass is called a specific latent heat. मीन्स जब latent heat को हम 1 kg मास से डिवाइड करेंगे तो हमको मिलेगा क्या? स्पेसिफिक latent heat. और स्पेसिफिक latent heat का फॉर्मूला होता है Q बाई M, और इसको हम ऐसे लिखते हैं Q इज इक्वल टू ml. ओके, where M is mass of substance, L is a specific latent heat of substance. Okay, and the SI unit of a specific latent heat is joule per kg. Now there is one more term, that one is called latent heat of fusion of ice, or we can say latent heat of melting of ice. Okay, so देखो जैसे मान लो solid liquid में convert हो रहा है. Okay, here solid is converting into liquid and there is phase change. So during phase change, here temperature remain constant. Okay, so this solid or this ice is converting into what? Water at 0 degree Celsius. Suppose this one is ice, this one is our water. Okay, so the heat energy absorbed when ice is converting into water, so there is absorption of heat energy. Okay, so the heat energy absorbed during this phase change, that one is called latent heat of fusion. Okay, and reverse, suppose we are doing reverse, when water is converting into ice at constant temperature, so again there is phase change, so that time the heat energy supplied, that one is called latent heat of freezing. So latent heat of fusion, latent heat of freezing. Okay, and here I have written one point, for pure substance the latent heat of freezing is the same as the latent heat of fusion. मीन्स फॉरवर्ड जाने में जितना एनर्जी ऑब्जॉर्ब किया, रिवर्स आने में उतना ही एनर्जी क्या करेगा? रिलीज करेगा. ओके, सपोज फॉरवर्ड जाने में इसने 420 जूल एनर्जी ऑब्जॉर्ब किया था, तो रिवर्स जाने में क्या होगा? ये अगेन 420 जूल ऑफ एनर्जी रिलीज करेगा. ओके, फॉर प्योर सब्सटेंस, नॉट फॉर एवरी सब्सटेंस. Now there is one more term, that one is a specific latent heat of vaporization and condensation. So now suppose here there is water, and this water at 100 degrees Celsius we are supplying heat, and this water is boiling. Okay, and now this water is going to convert into what? Steam or gas at temperature 100 degrees Celsius. Okay, so when water is going to convert into steam at constant temperature, so that time we are supplying the heat, so that heat is called what? A specific latent heat of vaporization. Okay, or we can say that the heat energy absorbed during the change of phase from water to steam, so that one is called latent heat of vaporization. And suppose we are coming reverse, this steam, suppose I want to convert this steam into water. So whenever we convert this steam into water at constant temperature, so that time this steam is going to release heats, and that heat is called a specific latent heat of condensation. Okay, and both these, for pure substance, this both the heat are same. Suppose it will take, suppose 410 joule heat energy absorbed during the change of phase from water to steam, so it is going to release same amount of heat, 410 joule, during reverse direction. Okay, while converting the steam into water.